Hi, welcome to this episode. Today we're going to talk about data wrangling. So this is really a quick start example. We're going to pull in some data, we're going to sort it and analyze it, and then draw a quick plot of that data. So this is a slide from a company called Trifactor. It's about the data wrangling process and how it fits into the whole data science pipeline. If you look on the left here, someone forms a question about the world or about a business, and then there's a whole series of stages before you get to the point where you're analysing the data and seeing some insight from it, which you can pass to a decision maker to help them understand and make decisions about this world or business question that you started with. You could compare it with all sorts of things. If you compare it with oil exploration, an awful lot of process goes into finding, capturing and delivering oil to refineries before it's turned into products. And that really is in some sense analogous here to what we're trying to do in data wrangling. Estimates are anything between 40 and 60% of all data science projects are in this phase where you're discovering data and working out how to form it into something that really works for you. These steps are typical, and of them discovery. If you don't know where data is, then it's going to take a while to find it. And even if you know where the data is, it might not be in a format that you want to use. In data structuring, you often need to form data sets into a new shape, and you'll see in a second how we're going to do that. But one typical example is where you want to bring in geographic location for something and plot it on a map. And that needs combining between your value data and your geographic location data. Cleaning, there's lots of parts to cleaning data, looking for missing data, checking for flagged false data. You'll see there's a flag in the data set we're going to use today for that. And basic examples of range checking. For example, sensor data can very often break down and go way out of range. And you want to exclude things that are obviously wrong from the data set. Enrichment, we'll see that here. We're going to aggregate some of the data to add extra value to it. And one of the things we're going to do is calculate hourly averages of temperature for Newcastle upon Tyne. Raw measurements themselves every 5 or 10 minutes are very often not what you need to present to decision makers. And so some form of analytics is always useful. And finally, validating. It's easy to skip this step, but it's well worth looking at data, how it has been wrangled, and whether the wrangled data is still accurate, because bugs, errors in the code can easily introduce large-scale errors in wrangled data sets. This is the Newcastle Urban Observatory. It's a source of data. It's a free source of data for Newcastle, and it's almost unique in the UK and the world in having data going back over 5 years about the city from sensors, and a whole range of different sensors: noise, weather, traffic, air quality. There's nearly 1.5 billion records in there, and they've been constantly inserted. If you go to the website, you'll see them updating all the time. You can pull this data back from an interface which gives you a spreadsheet, a CSV format spreadsheet, or you can access it through a RESTful API. In this example, we'll use pre-requested data, so we're not going to need to deal with the interface. So here is that sensor data pulled down from the Urban Observatory, and it's displayed in two different applications. The first one at the top is in Notepad++. So I tend to use this quite a lot for showing the raw text in a file. And also, if you see there's an encoding menu at the top, and that's good for checking that it's in the UTF-8 format, which Python uses. So that's the character set that Python likes to use. If it's not in that format, you can have problems reading in information in Python. Below that is Excel. Excel, extremely powerful software tool, and has many features in for data science. You can look at that in your own time, I guess. It's not really the focus of this course, but it is very useful for seeing what's in a file. You'll notice that there are some areas there, like the timestamp, which is not visible. That's just a case of adjusting the column width, and it'll show you the full timestamp if you do that. So I'm now going to show you this code, but running inside Visual Studio Code so we can execute it. Let's go to Visual Studio Code here. So this is an empty file at the moment. We're going to paste in some of this code. So here is the basics: import pandas as PD, common alias for pandas, a file name that we're looking for, and we're going to read it in as a data frame. Then we're going to do some filtering on the data. So we've read this in. We're going to create a new data frame called filtered. Most of what's happening here is we're changing the names of the different fields in the incoming data frame. This is partly to remove spaces from them, partly to make them more concise, so lat long instead of sensor centroid latitude. So there's one particular thing we're doing here. I'll highlight it just at the end. We're taking the date and we're processing it. We're doing two things to it. One, we're taking the raw string coming in from the file, turning it into a Pandas datetime type object. And we're doing that for the whole column of dates. And then we're filtering out the hour, and we'll need that later. So the hour is the number of hours in the day from 0 to 23, on the 24-hour clock in this case. And that's it. That's all we're going to do in this simple wrangling example. And then we're going to write that out to file. Okay, so that's wrangling the data. Now we're going to look at what we can do to prepare it and plot it. We're going to read in datetime, we're going to read in pandas, and we're going to read in matplotlib. So matplotlib is the main plotting library we'll use in the course. And we of course need the wrangled data. It's here. It's going to read in the wrangled data we just wrote out. Okay, once we've got that data frame, we're going to do something to it. So what are we going to do to it? In these three lines here, there's a set of things happening. We're going to extract from the column of sensor names a unique set of sensor names in this data file. So that will be just a list of each of the possible names for sensors. We're then going to filter the data, so we're only going to use a single sensor. So this second line filters the data to extract out a single sensor. Then we'll use the group by function to group data by a particular field, and in this case it's going to be by the hour, and then apply a function to each hour. And in this case the function we're asking for is the mean value. So the result of this will be a new data frame where every value in the original data frame has got the average calculated per hour. Now, there's a couple of important things here. One is that this only works for numeric fields, so this only works for numeric fields, and it will take a mean of every numeric field for the hour. For most of the fields here, that doesn't matter because they have the same value. The location of one sensor is the same. But it will also remove all of the string or text fields, non-numeric fields, from the data frame. So there's a few things that will happen there, but what it really gives us is this hourly average of data. So now I've added in the lines to do a plot. This is going to take a list of the number of hours, so each hour of the day, plus the temperature value for each hour of the day. And this is now the mean value, not the value, not all the measured values, but the mean value over that hour. We set up a title, mean hourly temperature. We extracted date and a sensor name for that title from the data. And that's quite a useful thing to do. When you're plotting data, try and extract as much of the information in the plot from the data as you can, particularly labeling and names and units. So we call plot to plot hours and temperatures against each other. We set the limit on the y-axis. We set the title. We set the x-axis to be an hour, label as an hour. We set the y-axis to temperature plus the units. And in the units, in this case, there's a field in the original data which tells us that we're measuring in degrees Celsius. We set it on a grid, and then we run plot show. And the result I'll show you here. So what we've taken is the data. We've plotted it for each hour of one day, and this day was the 21st of July 2018 for this sensor called per M1 mesh 1756150. And the temperature along the vertical axis is in Celsius. So we've extracted the Celsius label from the data, the date from the data, and the sensor name from the data. We've also made the y-axis 0, which isn't the default. And we've done that because we want this y-axis to be usually consistent, so that when you're comparing different plots next to each other, you kind of get the best idea of the size of changes in the data relative to 0. And that's the end.